Namaskar. In today's lecture of microwave electronics for the MSc Physics and Engineering classes, we will study about the excitation of modes in rectangular waveguides and the field configuration for the T and TM modes in rectangular waveguides. In our previous lectures, we have studied about the transverse magnetic and transverse electric waves in rectangular waveguides and various related parameters were also studied in the previous lectures. In the today's lecture, we will discuss that how the T and TM modes in rectangular waveguides are excited and what is the field configuration of the electric and the magnetic lines of force in these waveguides. So there are basically three methods for the excitation of modes. Number one is called the probe coupling method. Number second is called the loop coupling method, and third one is the aperture coupling method. The first two methods, that is the probe coupling and the loop coupling, are widely used for the excitation of various modes in rectangular waveguides. The following points were important regarding the excitation in waveguides, and these points are: number one, the field lines of any desired mode may be established in the waveguide by means of a probe or loop coupling device. Second point is a device which serves to excite a given mode in a waveguide can also be served reciprocally as a receiver or collector of energy in that mode. A probe should be located so as to establish the electric field lines of that mode. Next point is a coupling loop should be located so as to establish magnetic lines of force. And the another point is, if two or more probes or loops are to be used, then care must be taken to ensure the proper phase relationship between the currents. Now, in rectangular waveguides, the points which we have just discussed will be used for the excitation. In rectangular waveguides, as we know that the T10 wave or T10 mode is the dominant mode. The dominant mode is that mode for which the frequency for which the propagation may take place inside a waveguide is minimum among all possible modes in T and TM modes. In this figure, we have used a probe coupling. The probe is located at a distance lambda by 2 from the short-ended end of the waveguide. The coaxial line may be coupled to the waveguide by extending the center conductor of the coaxial line into the waveguide parallel to the electric field or near the point where the electric field lines are maximum. So this probe, this is the center conductor which will emit the electric lines of force. Now the another method for the excitation of T10 mode is by loop coupling. The probe was inserted in the wider dimension as shown in the previous figure, while the loop is inserted in the side dimension, which is shown in the end view of this rectangular waveguide. So this is the loop. Around the loop, the electric currents will be produced, which will cause the magnetic lines of force to propagate, and the time varying magnetic field will produce the electric lines of force. So this is the principle of the coupling by loop for the excitation of the dominant T10 mode inside the waveguide. So in the waveguide, usually one end is closed and probe is located at 1/2 wavelength from the closed end, so that the two waves from the probe are reinforced by waves reflected from the closed end of the waveguide. Other modes, that is the higher order modes, may also be produced. For example, if we have to excite T20 mode, then as shown in the figure, two probes were inserted in the broad wall of the rectangular waveguide. By splitting the one probe with the help of a coaxial line into two probes, and these two probes were shown as in the figure. So in this way we may excite T20 mode. Similarly, TM11 mode may be excited by inserting antenna probe in the end wall of the waveguide. So it means if the probe is inserted in the shorter or end side of the waveguide, it will excite TM11 mode, while as shown in the first figure, if the probe is inserted at λ/2 distance from the closed end in the wider dimension, then it will excite the dominant T11 mode. So these are the methods of exciting the various modes. Now we will discuss the field configuration of lower order T and TM waves in the rectangular waveguides. So in this first figure, which is the top view for the T10 wave, so in this figure we have shown the magnetic lines of force by the closed loops as viewed from the top of the rectangular waveguide. So this is the case for the top view. So this is the figure for top view. Now in the second figure for the T10 wave, we have shown the side view. So the solid lines are in the figure are the electric lines of force. So after each lambda by 2 distance, the direction of the electric lines of force will be reversed, and at the points where the density of the lines is shown larger, for example these arrow marked lines at these points. So these are the points where the strength of the electric field is higher, and as the distance between the electric lines of force is shown with increasing order, then it means that the electric field will become weaker. Similarly, in this third figure, this shows the end view. So this is the end view in which A and B, these are the wider and the shorter dimensions. The electric lines of force, these are shown by solid arrow marked lines, while the horizontal dotted lines shows the magnetic field lines. Similarly, for the TM11 wave, the top view and the end views, these were also shown in the figures. So in the end view, again the solid lines in the figure shows the electric lines of force, while the closed dotted loops shows the magnetic lines of force, and in the top view the electric lines of force, these are the solid lines, while these circles in between the electric lines of force, these shows the magnetic field lines which are perpendicular to the electric lines of force. So this is about the field configuration of the various lower order modes in rectangular waveguides. In our next lecture, we will discuss the TM and T waves in the cylindrical waveguides. Thank you.